Hello guys, this video will be talking about the criss-cross method. We will learn how to do the criss-cross method in order to get the formula unit of ionic compounds. Then we're going to name these compounds. So let's start with some examples. The first examples we're going to tackle is between aluminum 3+ and Cl-. So as you can see here, the charge of Al is +3 and the charge of Cl is -1. So the cross or the criss-cross goes like this. This one is moved into a subscript for Al, and this 3 is moved into Cl as a subscript. So the compound that you're going to get is AlCl3. Now, as you can see here, this combination is between a cation, Al3+, and an anion, Cl-. And you can notice here that both are monoatomic. So both of them are monoatomic ions. You just cross them without the charge, you get AlCl3. What does this mean? This means you have one Al3+ and 3 Cl-. This is your formula unit. This is done to balance out the charge within the compound. Of course, the one that came from Cl, we put it here, but usually we don't write 1. Now we need to name this compound. Because this is ionic, we named the first part, which is the monoatomic cation, then the other part. So this is aluminum chloride. Pay attention that you replace the INE in chlorine or chlorine with IDE. You do this for all monoatomic anions. So just a reminder for the naming part here of the anion. If you have oxygen 2-, the name becomes oxide, the name of the anion. If you have sulfur S2-, it's sulfide, and so on. You have a table of these anions which you need to memorize with their names. Now another example. Let's take another example. So our next example is Mg, magnesium, and oxygen. If you go and check the periodic table, or if you already memorized the ions, Mg is in group 2, so charge is 2+. Oxygen is in group 16, 6 valence electrons, needs 2 more to fulfill its octet, so needs to gain 2, 2-. Now we're going to do the criss-cross method. If you're supposed to do it, this 2 will go here and this 2 will go here. But in the case where you have similar opposite charges, like +2, -2, +3, -3, even +1, -1, they just cancel. The charges just cancel out with each other. And the compound that you will get here, because these charges cancel out, is MgO. So you don't put the 2 here or the 2 here. This is your ionic compound. Now we need to name it. This is magnesium. You start always with the cation, then the anion, magnesium oxide with IDE at the end. So this is your ionic compound. Now let's take an example which involves polyatomic anion. Let's try copper and nitrate, NO3 minus. Of course, this minus charge is for all of it, for N and O together. I'll tell you that copper here has a charge of 2 plus. So this is 2 plus. So what should we do here? Crisscross. This is 1. So this 1 goes here for the copper as subscript. This 2 goes for the nitrate, the whole of nitrate. Okay, so not just for the oxygen or not only for the nitrogen, but for the whole of it. You treat NO3 minus, the nitrate ion, or any other polyatomic ion as one unit. Okay, so the compound here would be Cu1, and I told you we don't write the 1, NO3, which is the nitrate, and it has gotten a 2 from copper, so you put brackets and you put 2. When do we put brackets? When you have a polyatomic anion and you have a number here as a subscript other than 1. So let's name this. This is called copper nitrate. Now pay attention to something really important here we've missed. Copper, if you refer to the tables that you have, can exist as Cu plus or Cu2 plus. So it has two different oxidation states or charges. To distinguish between the two, in the name, we use Roman numerals. So this is 1 and this is 2. So in the name, because copper has two different oxidation states, I would write a Roman number 2 to indicate that this is the charge or the oxidation state of copper. You do this for all ions that have more than one oxidation state. The most famous examples are copper and iron, Fe, which has a charge of 2 plus or 3 plus. So if in your compound you have iron 2 plus, you put Roman 2. If you have iron 3 plus, you put Roman 3, and so on. So this is really important to know, and you have to put the Roman letters within the name. So let's take one more example, just to make sure that you have understood this part of crisscross. Let's take copper 2 plus and sulfate SO4 2 minus. Now, what would the formula be in this case? I'll give you a few seconds to think about it. So if you did the crisscross here, you shouldn't. So because these have opposite charges, plus 2 and minus 2, they just cancel out and you get CuSO4. So this is copper sulfate. Now the systematic name, you should put a 2 here in Roman, but for ages people have known this compound as just copper sulfate. So copper sulfate or copper 2 sulfate, both names are acceptable in the case of CuSO4. Another example, last one, which we will use the ions and name the compound after. Let's take as an example sodium Na plus and carbonate CO3 2 minus. So here they have different charges, +1 and -2. You have to do the cross. This one from Na goes here, this 2 goes here, this is your crisscross. You'll get Na2. Where did this 2 come from? From this CO3 2 minus, and CO3, there's 1 here, but we don't put 1, so your compound is Na2CO3. Now to name this compound, first part sodium, this is sodium, and this part is carbonate. No need here to include Roman numerals because sodium has only one oxidation state, which is +1. Usually Roman numerals are used for transition metals. So this is your compound, this is your formula unit, and this is the name, sodium carbonate. I hope you guys memorized the tables which contain the ions with their charges, and then practice by yourself.